You ever try to picture the fourth dimension? It's one of those things that just feels impossible, right? Like trying to imagine a brand new color. But what if there was a way to see its reflection in our world? Not as some weird, distorted picture, but as a kind of map. A map of hidden connections. Well, today, we're going to dive into a visual tool that tries to do exactly that. So, yeah, this is the big question, isn't it? Our brains are just not wired for four dimensions of space. So, how could we possibly begin to wrap our heads around it? Well, it turns out the secret isn't about trying to look at it directly, it's about learning how to read the clues it leaves behind. And this image right here, it just perfectly nails the core idea. Think about it. A 3D object, like your hand, casts a 2D shadow on the wall. So it follows that a 4D object could cast a 3D or even a 2D shadow in our world. And by studying that shadow, we can start to figure out the shape of the original thing. So what you're looking at here isn't just two circles. It's the very beginning of our map. All right, so let's break this down. Where does a shadow like this even come from? We're going to start with a perfect, elegant object in 4 dimensions, and then we'll watch what happens as it sort of falls or gets projected down into our familiar 2-dimensional world. Our starting point is this thing, a 4D hypersphere. Now, it has what mathematicians call SO4 symmetry. That's just a fancy way of saying it is perfectly, absolutely symmetrical. Imagine you could rotate it in any of its 4 dimensions, and it would look exactly the same. It's really the ultimate balanced object. So what you're seeing here is this kind of dimensional collapse in action. As we project that perfect hypersphere down from 4D to 3D, it loses some of that magic. It becomes just a regular old sphere. Then, when we flatten that sphere into a 2D shadow, it loses even more, leaving only the simple symmetry of a circle. You see? With each step down, a layer of its complexity, of its perfection, is just forgotten. So these simple circles, they aren't just some random design. No way. They're the last surviving echo, a ghost, really, of that perfect 4-dimensional shape. It's like the memory of that perfect symmetry is the only thing that survives the fall. Okay, but there's a problem. That 2-circle shadow, it's a little unstable, a little blurry. To get a clearer picture, we need to upgrade the diagram. We have to add a kind of corrective element, almost like you'd add a new lens to a camera to bring everything into focus. And the solution is actually pretty clever. We just add a 3rd circle. But this one simple addition fundamentally changes the entire structure. It's not just a blurry projection anymore. It becomes a stabilized, reliable map. This new element doesn't just add more information, it organizes the whole thing. The source material uses a great analogy for this. Think of it like a high-quality camera lens. The first 2 circles create the basic image, sure, but that 3rd one acts like a corrector. It removes all the distortion and gets you that super sharp focus. And the result is what the source calls a scale-invariant mandala, basically a stable pattern that holds its structure no matter how you look at it. Okay, so we've got a stable map. What can we actually do with it? Well, this is where it gets really, really interesting. We can use it to plot abstract ideas. For instance, let's say circle A represents sand dunes, a very slow geological process. And circle B represents rivers, a much faster process. And circle C, well, let's make that time itself. All of a sudden, the intersections start to mean something. You get river turbulence, dune migration, and right there in the middle, a unifying concept of scale-invariant flow. Now that's powerful stuff, but we can push this even further. To get the truest possible 2D representation of our 4D object, we need one more piece of the puzzle. This is going to give us the full picture. And here it is, the final form, the 4-circle hypervenn. This tetrahedral shape is considered the most natural 2D shadow of a 4D symmetry because it perfectly preserves the complicated relationships between 4 totally different domains. Look at how each circle touches every other one, creating this beautiful, interlocking system. So what can we map onto this beast? Let's get really ambitious and use some fundamental concepts from physics. We can assign one circle to the real domain, stuff we can see and measure, another to the imaginary domain, the hidden forces and structures, a 3rd one for time, and the 4th for entropy, which is basically the tendency toward disorder. And just like that, the diagram becomes a map of a whole unified system, and it all comes together right here, in the dead center. This little diamond shape is where the real, the imaginary, time and entropy all meet. The source calls this the dual reality mandala. It's like the symbolic engine room, the point of convergence where all these seemingly separate forces come together and unify into a single, elegant, scale-invariant law. So let's just step back for a second and look at what we've done. We've gone on a journey from a simple, blurry shadow all the way to a complex, stable map. We took an object we literally cannot see and built a tool that lets us understand its structure and the relationships it governs. And this, right here, is the ultimate takeaway. This Hypervenn diagram, it's not just a pretty picture. It's what you'd call a tool for thought. It's a framework that lets our 3D brains visualize the deep, hidden connections between different parts of our world. Whether that's dunes and rivers or time and entropy, it's a whole new way of seeing. Which, of course, leaves us with one last really fascinating question. If a diagram like this can help us glimpse the structure of another dimension and the laws that unite these complex systems, what other profound connections in our universe are just sitting there, waiting for someone to finally draw the right map?